Okay, it's going. All right, so here we go. 1.2. Today we're going to talk about two things. Pretty much this. You will talk about graphs and equations. Okay. So equations, if you look at an equation and you want to know what it looks like, you have to graph it. Every equation is a graph. Okay. So today's goal, students can understand the relationship between an equation in two variables and its graph. So every equation is a graph. We got to figure it out. Students can identify the x and y intercepts both graphically and algebraically. Graphically, we're going to do it with our calculators. Algebraically, we're going to do it with our pencil and paper. And then last, this is the one I did not make in period 4 or 5, students can test for symmetry of a graph both graphically and algebraically. Now, graphically is easy because we just type it in our calculator, we look at it, and we go, oh, it's symmetrical to the x-axis. It's so easy. But algebraically, it's not easy, and we didn't make it today. All right, but we'll get there tomorrow. If you guys have noticed, this lesson takes 3 days. I'll get most of the talking in today. Tomorrow will be less talking, and Monday will be much less talking. Okay, here we go. So you will look at most problems in this section graphically, numerically, and analytically, and verbally. Now, graphically, I just mean you're going to take it and you're going to actually what? Graph it. Yeah. It might be a line. Sorry, I didn't mean to do this one, but what is that? You guys remember what that is? And what kind of equation is this?
Absolute.
It's an absolute. Good. That's good, John. It's an absolute value. I didn't mean to do that. I was trying to make a U. What's this?
Parabola.
That is a parabola, but where did that come from? What kind of equation? Quadratic. Where did this come from? Linear. Okay. And where did this one come from? Absolute value function. Yeah, so you guys remember some stuff. That's great. Numerical. Numerical means look at an equation and start making what? Start making a table. So you can look at equations, you can make tables. Analytically, it just basically means use your algebra skills. I'll say algebra 2 skills because most of your skills come from algebra 2. Okay? And verbal just means use your words. Okay? When I say use your words, you could look at an equation and you could say the y value is twice as big as the x value. You could actually use your words and you could write it out that way. Okay, so there's actually 4 ways we can look at equations and actually tackle them. We can graph them, we can make tables, we can use our algebra skills to work it out and figure out answers, or we can just use our words. All right, now here's where we actually start our notes. Here we go. You need to start writing things down now. Discuss with the people around you the method you would use to answer the following question. Here's the question. Does the point with the coordinates negative 2, 1, does that point lie on the graph of that equation? Does that point fall on the graph of that equation? How would you figure that out? Talk to your partner.
You can do that, or you can just
Yes or no? Did it fall on the graph?
Yes.
Yes. Okay. How did you and your partner say? Let's do it this way, John.
I plugged it in. Since 2 and 1 are both x and y.
Yeah.
I plugged negative 2 to x and 1 to y. So negative 2 squared is 4 and subtract 3, that's 1.
Okay, so you went negative 2 for x, right? Squared it, minus 3. Put the 1 in for y like that.
Yeah.
Okay, and then you got 1 equals 4 minus 3, which is 2. Right? 1 equals 1. Is that true? Sure. So this is true. So the second you say it's true, that point satisfies this equation which means that point is on the graph. So to be a solution, every point has to make the equation what? True. So if I found all the solutions, this is what this is now. If I went out and found a whole bunch of these solutions, could I just graph them all and get the picture? Could I get the line or the parabola? Sure. So basically, all the solutions make up the graph of the equation. All right, this is on the graph because it makes it true. What if it would have been 4 equals 1? Then it's not on the graph. It missed the graph. It's off the graph somewhere. Okay, so the answer was what? Yes, it's on the graph. Okay? That's how easy that is. That's how your assignment starts today. Okay, look at this equation right here. Y equals what? 2x minus 3. I gave you a table. I gave you a graph. Are these points on there for you? Yeah? Okay, so here's what it says. This Algebra 1 problem is partially done for you. I did a couple points for you. What do you know about the equation right here that helps you know how to complete this graph? Give me some things you know.
Slope.
What?
Oh, slope.
Oh, you know the slope. Okay. Okay. Naomi, what is the slope?
2.
She says the slope is 2. What does that mean to you, Naomi?
Isn't it up 2 over 1?
Up 2 over 1, like that? Okay. So you know what? If you say it that way, can I write it as a fraction?
Yep.
That's what I do. I write slope as a fraction. So to me, the top number is always your what?
Rise.
Rise. And this is your what?
Run.
Run. So is she right?
Yes.
Up, 2, right, 1, up, 2, right, 1, up, 2, right, 1. Yeah, I mean, they could have put another one there, I suppose, right? Okay. So slope. Where does the slope hang out? Where'd you find this? Why did you say the slope was 3?
It's the x. It's the coefficient.
So it's the number, it's the coefficient in front of x, isn't it? Okay, good. So that part we knew. Anything else?
-3 is the y-intercept.
Okay, so the y-intercept, John throws this word at me. He says the y-intercept is -3, which if you're going to say the y-intercept, you're talking about this. 0, comma, -3. And by the way, if I did the table, 0 goes in, guess what comes out? Yeah, so John says -3, the number without the x is the y-intercept. So we knew that. Okay, so we knew that. What else do we know? How'd you know it wasn't a parabola? How'd you know?
It wasn't squared.
It is an x squared. It's x what?
To the first.
X to the first. And this is y to the...
First.
So when your variables are x to the first and y to the first, what do you know about this equation? It's known as linear. Okay. And once you know it's linear, you're thinking the graph is a line. And what I knew it was a line. I knew the slope was 2. I knew the y-intercept was -3. I can make this table if I want. What's this going to be? 2 goes in, 1 comes out. -1 goes in, -5 comes out. Okay, so you can do the table. You can take information you already know. And by the way, the next lesson, 1.3, guess what it's about? This. This is known as y equals x plus
Y equals mx plus b.
and that is called slope-intercept form. Yeah, guys, I'm trying to pull it out of you. This is what the next lesson is all about, slope-intercept form. That's where we're going in 1.3. Okay, so we're done with that. Let's keep moving. These 4 points that I gave you in this slide from Algebra 2 indicate solutions to a function. So this is a solution, this is a solution, solution, solution. Solutions are on the graph. Now, predict. Predict, that means you might be right and you might be wrong. Predict what the complete graph could look like. Draw a picture. I don't think it's a line. Don't draw a line because it's not going to work. You're just guessing. I gave you 4 solutions to your equation. You got them. Now can you graph it? I'm I'm gonna take one look at somebody's paper. Okay. Whose paper am I gonna look at? Right here. What'd you do? Oh, just what I thought you'd do. Okay. Here's what I saw. Chloe goes like this, Chloe goes like that. Who else did that? Boom, 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 boom. Oh, everybody, everybody. Okay, so you guys all thought it was a parabola. You all thought it was quadratic. But here's the deal. I gave you solutions. I never gave you what? The equation. Guess what it was? Look at your next slide. It was this. Okay, so you guys thought it was a parabola, but it went like this and it went like this. You cannot graph anything until you know what the equation is. Do you have any clue what this equation is? It's x to the what? 4. Do you know what we call those?
Not friendly.
Not linear, not quadratic.
Quartic?
Quartic, there it is. You got a quartic function. Now, do you remember anything about quartic functions from last year? Anything? Remember how many times?
3 terms?
Good job. It's a 4th degree polynomial. Subtract 1 from 4, you get what? 3. They can turn how many times? 3 times. There's 1 turn, there's 2 turns, there's 3 turns. Yeah, I can turn 3 times. Okay, remember that? It doesn't matter if you remember it. We're going to talk about that stuff later, but I just wanted to throw that at you. But here's the thing. If I give you solutions, yeah, they're points, but you can't graph it until you know what? You got to know the equation before you can graph it, okay? All right. Does that thing look symmetrical at all to you?
Yeah.
What's it symmetrical to? Yeah, it is, the y-axis. And then symmetrical is really nice, guys, because if this number right there happened to be 6, 0, then way over here, this would be what? Negative 6, 0. So symmetrical is really nice because you only have to graph one side and then mirror it across, okay? All right, approaching a problem graphically. When you look at an equation, you can look at it in different ways. Graphically is kind of nice because if you look at the graph, you can see it and you can answer questions. So go ahead, use your what? Graphing calculator. To view a graph of each equation, use the graph to approximate the x-intercepts and the y-intercepts. Just tell me what you know about x-intercepts. What is it that you know? What is an x-intercept? It's, yeah,
Intercepts.
it's where the graph does what?
Touches
Touches the x-axis. It goes right through it. So what would this point be? Don't look down here. Just tell me what it would look like. Boom, boom.
0.
What is 0?
Y 0.
Y is 0. Got it. That's it. The y value will be 0. The x value will be what? I don't know. We're going to go find it. Now, in the y-intercept, what do you know? Which one do you know?
X is 0.
X is 0. Y, you have no clue what it is. No. But we're gonna find it out. All we're gonna do is graph these. Now, when you graph this in your graphing calculator, you can't until you do one thing, and that is solve it for y. So if you solve this for y, it's y equals, slide the 2x over. 2x plus 5, got it. Okay, now here's where we can get started. Let's plug it into our calculator. And I don't know how much you know about this calculator, so we got to start slow. First of all, if you turn it on and you have this look, just something like that, you don't want that. You want to start from scratch. So you go, here's what you do. You hit second, and then right next to that is mode, but that really means second what? It doesn't mean mode, it means second quit. And quit gets you back to the home screen. Go back to the home screen. Second quit. Okay? Once you get this blank screen, if you have something on there, like let's just pretend I got a bunch of 8s on there, hit clear, get rid of it, okay? Now, what we want to do is put the equation in. How do you put equations in? Y equals, right here. y equals. Now look at the mess I have in there from last hour. I want to get rid of that. How do I get rid of it? Clear. So you clear yours out. If you have something, clear it out, okay? Now what's the equation we're putting in? 2x plus 5. Okay, here's the 2. That's easy. Where's x? X is right next to alpha. It's right here. This is the variable x right here. Next to alpha, to the right. Hit x. Plus 5. Okay, I got it. 2x plus 5. Now, when you get to your assignment tomorrow, it will say this. Graph this equation on a standard window. A standard window is this. 10, 10, 10, 10. Okay, everywhere you go, it's 10, 10, 10, 10. How do you get a standard window? You hit the word zoom right here. Hit zoom. Right there, number 6 is a standard window. So just hit number 6. And right now it's going to start graphing. Here it goes. Boom, it's a line. It graphed it for us. Now, your job is simple. Find the x-intercept. Find the y-intercept. That's it. Well, you can visually kind of see it, but there is a trace button right here. The trace button is kind of nice because wherever it's flashing, it will tell you the coordinates. I'm right now at what? Yeah, this is the y-intercept. 0, 5, right? 0, 5. Okay, so you've already got one answer. 0, 5 is the y-intercept. How do I get to the x-intercept? I start scrolling to the left, and I just keep going until I pretty much get there. And I won't know until I get there. I got to get that y value to say what? 0. I have to get this to become 0. Not there. Oh, guess what just happened? I was above it. Now I'm below the x-axis. So let's go back above it. So I'm 0.15 above. I'm 0.15 below. So what do you think the answer is? It's kind of in the middle of these two, isn't it? Here I'm below the x-axis. It says negative 2.57. Here I'm above the x-axis. It's negative 2.442. I'm sorry, I got lost there. What do you think it is? Okay, let's try that again. Here it's a little above, and the x value is negative 2.42. Here it's a little below. It's negative 2.57. So it's got to be in between negative 2.42 and negative 2.57. 2.5. I guess right in the middle, yeah. So here's the deal. If you ever want to know if you're right, am I right to negative 2.5? Here's what you can do. Watch. Second. Above the word trace is called calculate. And it says what? Value. Give me a value. Hit enter. And right there, guys, you can ask your calculator when x is negative what? 2.5. What is the y value? Well, look, it's going to say 0. So our guess was perfect. We have a perfect guess. It's negative 2.5. That's the answer. So fill it in. What are the answers for this one? This one, it would be what? Y-intercept was what? 0, 5. X-intercept was what? Negative 2.50. There you go. Got it. Graphically, it's kind of cool because if this thing graphs it for us, we can pretty much get it. Okay? Try that one now. A little more on your own. When you go back to your calculator, hit y equals and get rid of the other equations, hit clear, and then put in x squared minus 6. Okay? See what happens there. Was it x squared plus 6 or minus? Minus? Okay, minus 6. All right. I've got mine in. Do you have yours in? You don't have to hit zoom standard window. You already have a standard window. graph. Here comes mine. Okay, it's not a line this time. It's a what? Parabola, because it was x squared. It's quadratic. Okay. Anyway, so that's it. Now go get your intercepts. By the way, how many y-intercepts are there? 1. How many x-intercepts? 2. Okay, so let's go trace. And right now I'm right on what? I'm on a y-intercept. The answer's done. I'm done. It's 0, 6. Okay, now let's go get the x-intercept. Trace it. Kind of just go right until you come up to the x-axis. I'm just about there. Actually, I am a little bit below the x-axis because it's negative 0.12. Let me go one more. Now I shot up way high. I'm over halfway above, so this is 0.6. So this answer is too big, and this answer is too small. But which one seems closer? The 2.42 or the 2.57? Yeah, 2.42 seemed closer. So let's just guess a little bigger than 2.42. Like 2.5. 2.5. Are you right? Let's see if Hunter's right. Second, calculate. Give me a value, number 1. Okay. I'm going to guess 2.5. 2.5. Well, actually, Hunter, you guessed it. Okay. What does it say? At 2.5, where are you at? You're up a quarter unit. Okay, you're a little above the x-axis, so come down a little bit with your 2.5. Now remember, 2.42 is too small. 2.5 is too big. Go in between. In between, say it again.
2.47.
2.47, let's try it. Ready? Second, calculate. Give me a value. 2.4. Come on, 47. 2.47. See you guys.
Yeah, see you.
Good luck. Somehow I locked up, guys. I'm locked up. Did anybody try 2.47? Was it close?
0.1009.
0.10. So 0.10. You're actually still a little high. You know what? I'm going to tell you what we actually found. In period 5, we actually found it was it was actually 2.45. 0. Okay.
But I put that in
What did it come out as? 0.00. Yeah, it's not. I mean, this is an estimate. This is just an estimate. So looking at the graph is really hard because the calculator has a hard time locking in on it too. But there it is. But wait a minute, wasn't there 2 of them? Yeah, guys, when you look at it, there's 2 of them. And did you notice it's a parabola? You notice it looks symmetrical. So if 2.45 works, what do you think this one is? Negative 2.45. Yeah, you can check it out. Check it with the calculator. It will work. So I'm going to say x-intercepts. Right here, x-intercept, plus or minus 2.45 comma 0. What was the y-intercept on this one? 0, negative 6, okay? And there was only one of these, right? Only one y-intercept. Good? Okay. Graphically, kind of nice because it will do the work for you. But actually, to type it all in and then look at it takes time. This is you doing it by yourself, approaching a problem analytically without your what? Without you using your graphing calculator. So use substitution to find the x, y intercepts. So if you were to try go get this, let's go get the x-intercept. Now, if you're going to do it by paper pencil, it's really simple. You should know the x-intercept is something for x. What's y? 0. So if you know half the ordered pair, just plug the 0 where? Plug it in for y. 2x equals 8. What's the answer? 4. Okay, you got it. We're done. When you want the y-intercept, it's the same thing, except what do you know about the y-intercept? This time you know what?
Plug it in for x.
Yeah, 0 is the x value, right? Okay. So we plug this one in. Right about here. If we did that, it's 2 times 0 plus y equals 8. Well, we know this is gone. What's the answer? Y is 8. Okay. There you go. 0, 8 is the y-intercept. 4, 0 is the x-intercept. Good? Okay, there's one more right here. I kind of boxed it off on you. Do another one. Here we go. This is more for you, not me. Okay. Try that one. Y equals x squared minus x. Okay, there's me putting in zeros. Okay, I want the x-intercept. I want this number. Put 0 in for y. There it is. I want the y-intercept. Put 0 in for x. Here's the equation now. Okay, which one of these two is really simple? Y. Yeah, go find the y-intercept. Well, y-intercept is what? 0 squared minus 0? 0. Guess what? What is the y-intercept? It's the origin, 0, 0. That was easy. This one's not so easy. How'd you do it? What's the x-intercept? I mean,
0.
0? Because 0 squared minus 0 is 0? Is that why you said that? Okay.
Also because
Because
if
if,
y or if that one's going through the origin, it means it has to go.
yeah, the origin would be the x and the y-intercept, right? Yeah, you're right. So 0, but 0 works. 0 squared minus 0 is 0. That works. There is another one.
1.
1 squared is 1, minus 1 is 0. It works. You got it. But that's not the way I want you to do it, because are you going to sit there and try to pick out answers? I think it's 0, and I think it's 1. Well, that's too hard. What if the answer was 1.75 and negative 3.9? You wouldn't want that. You wouldn't want to be picking a number. So really, do you guys remember this at all? When you are looking at what kind of equation is this? Quadratic. How do you solve it? Quadratic formula?
Oh, I was right.
Close.
But I would never recommend doing that until, that's my last ditch effort.
So it is binomials.
You're on the right track. You're just not, you're not saying the right word. Starts with an F.
Factor.
Factor. You factor quadratics. It's the best way to do it. So here's the deal. Your factoring skills come into handy now. The first thing you do when you factor is always look for what? Greatest common factor. Do you see something these two terms share? X. Take out what? X. X times what? X minus 1. There you go. Now once you factor it, what you do is you say, when will this factor, x, times this factor, x minus 1, when will these two factors equal 0? Well, when one of them happens to be 0. When is this one going to be 0? We'll just set it equal to 0. Oh, it's done. So one of the answers is what? 0. When will that factor be 0? We'll set it equal to 0, solve it, and you get what? 1. There's the other answer. So what are the x-intercepts up here, guys? 0, 0, and 1, 0. There you go. You don't want to guess. You two guessed, and you guessed them right, but that's not always that easy. Okay. So you want that factoring skill to come back. Okay, and we'll be factoring as we go. Okay. So that's how you do the x-y intercepts by using your algebra skills. Okay. Here comes your symmetry. There are many graphs are symmetrical, and they can be symmetrical according to the what axis here? Y. This one is symmetrical to y, and the nice thing about that is if you knew this point was 2 comma 10, do you know this point over here? Negative 2 comma 10. Yep. That's what's nice. You get a freebie. 210. Oh, negative 210. Now when it's over the y-axis, what do you notice about the ordered pairs? Look at the ordered pairs. 210, negative 210.
Only the X.
The x's are what?
Opposite.
Opposites. When you reflect over y, the x's are opposite. Okay. When you reflect over x, if this point happened to be 10, 3, what's this point?
Negative, 10, -3.
10, negative 3. So what are you noticing, guys? When reflecting over the x-axis, what do you notice? The y's are opposite. Okay, good. There's one more reflection or symmetry, and that is origin symmetry. Okay? Which basically means this. This point can be reflected through the origin. And if you went through the origin, it'd be kind of like this. Right about there. Now, the thing about reflected through the origin, what really happened is this. This point just got reflected over the x-axis, then it got reflected over the y to hit that spot. So if this point happened to be 1 comma 10, what's this point? Negative 1, negative 10. Yep. So when reflecting through the origin, what happens to the ordered pair? Both are opposite. So whatever x is here, it's going to be negative x here. If this is y, it'll be negative y there. So important that you know that, okay? Okay. Use your graphing calculator right now. Type this in and tell me what this is symmetrical to. The x or the y or the origin. Your calculator will tell you. Once you graph it, you'll see. And then make a sketch. Just sketch it. Go to y equals, type in x to the fourth, minus x squared, minus. Take graph. Standard window again, just 10, 10, 10. So what's it symmetrical to? Okay, people have got it. Some people have it. Some people are still punching it in, but it kind of looks like this in it. And it went like that. Right? Okay, so what'd you say? What type of symmetry does this function have? Y-axis. Okay. Anybody not get that? Couldn't get the picture to come up?
Because I can't. I just don't know how to use it.
Oh, but is it graphing?
No.
Well, that's why you can't graph it. You got to use mine. But what do you think?
I
Do you have a graphing or not?
Yes, I do. Oh, I just don't know how to put.
Okay, ready? X. Raise it to
I'm so used to it.
Don't you see it?
No, I'm just saying I'm used to it.
Okay.
I didn't, all right, then I can.
Got it? Okay. Get it to see if you can get to work here. Okay. All right, guys, that's it. Now, next slide. With respect to the y-axis, what point is symmetric to to one with coordinates 2, 3? Okay, so with respect to the y-axis, here's 1, 2, 1, 2, 3, right here, 2, 3. So guys, reflect that over the y-axis. What's the point over here? Negative what? Okay, negative 2, 3, right? You go straight across, there it is. Now, one more time, what did you notice about reflecting over y? When you reflect over y, what happens? X's are opposite, okay? Now reflect it over the x-axis, this way. You'd be about right here. This would be what? 2, negative 3. You are now noticing when reflecting over the x-axis, the y values are what? Opposite. Okay. I know I'm kind of hammering this in your head, but you got to know this to make it make sense later. Okay, now do this one. Did you already see that, or was that on yours? Okay. What are the coordinates of the point symmetric to 1 with coordinates 4, negative 3 with respect to the origin? If you go through the origin, guys, if you go right through it, hit it, that distance must equal this distance right here. When you think about, that's how I think about going through the origin, but really by definition, what it is you reflect it over the x, you reflect it over the y, you land right here. So what would this point be? Say again? Yes. And when you reflect over through the origin, the x's are what? Opposite. The y's are what? Opposite. All the time. Okay? This is where we got. You guys actually have more time than any other class. So, can I just read this to you? Because really, we're not going to do anything. I'm just going to read it. See if it makes sense. Then that's where we'll quit. If, when you replace the letter x, or the x variable, with what?
It's opposite.
It's opposite, negative x. The equation is the same when simplified. The equation is symmetric with respect to the y-axis. Okay, so tomorrow when you get here, we're going to take an equation, and we're going to replace x with what? Negative x. And then we're going to work the problem out. And if it happens to be the same, it looks identical, then it is symmetrical to the y-axis. Okay? And we'll do it 3 times. We'll test it for y-axis, we'll test it for the x-axis, we'll test it for the origin. So when you get here tomorrow, we're going to do those 3 tests. And then the last part of the lesson is talking about circles. Okay? I think we're going to quit there. When you do your assignment, I don't believe you are able to do these, because these talk about the symmetry test, and you don't know about it. Okay? Now, that half sheet of paper I gave you, right here, this half sheet of paper is problem what? 41, 43. Even though your calendar says don't do 43, do it anyways. So let's do 41 and 43. These 2 problems actually will take you less than a minute. They're really easy. I just wanted you to try 2 of them.
He said he wanted to be slow.
Okay. This lesson 1, 2 takes us about 3 days, so it's kind of a long one.
So will we just keep adding back the 33?
Yeah, we'll add them tomorrow. Yeah. I just, time-wise, I got to take that off for next